Alright guys, so this is our second video for our Flip the Classroom lesson on the polar coordinate system, or the polar plane. And in this video we are going to talk about taking a point defined by polar coordinates and represent it with its corresponding rectangular coordinates. And we're going to talk about taking a point defined by rectangular coordinates and represent it with its corresponding polar coordinates. Now remember that rectangular coordinates are the x and y values of an ordered pair that define a point on the xy axis, or on the rectangular coordinates, or the Cartesian coordinate system. So right here, in general, what we want to think when we're looking at a point, whether it's defined by rectangular coordinates or polar coordinates, is that it's really just a point on the plane, and whether we're representing it with polar coordinates or rectangular coordinates, it's the same point. When we talk about polar coordinates, it's just a way of defining that point's position from the origin as a distance in a direction. And when we talk about with rectangular coordinates, it's a way of defining that point's position with regards to its horizontal and vertical displacement from the origin. So really, this point is the same point whether we're defining it with rectangular coordinates or polar coordinates, right? So right here, if we're looking at this point defined with polar coordinates and we want to convert it to rectangular coordinates, what we can think is that the distance 3 in the direction 120 degrees could also define the magnitude and direction of a vector extending from the origin to this point, right? So right here, we know that component form of a vector with its tail at the origin is going to have the horizontal component of the x value at the head of the vector and the vertical component of the y value at the head of the vector, right? So horizontal and vertical components directly relate to the x and y value of the ordered pair at the head of the vector. So right here, what we can do, if we think about r as being magnitude and theta as being direction, for a vector, we can say that component form of the vector extending from the origin to this point would be represented by 3 cosine of 120 degrees, 3 sine of 120 degrees, where 3 cosine of 120 degrees is the horizontal component and 3 sine of 120 degrees is the vertical component. And then basically, if we just evaluate the horizontal and vertical component here, we're going to get negative 1.5 and 2.6 as the horizontal and vertical component of the vector extending from the origin to that point. And that, of course, means that the ordered pair at the head of the vector is going to be negative 1.5, 2.6. And that's going to be the point that we've got right there defined with rectangular coordinates. These are the rectangular coordinates of that point. So right here, moving on, if we want to convert a rectangular coordinates to polar coordinates, we can use this same line of thinking. So right here, I've got a point 3, 2, and I know that if I extend a vector from the origin to this point, then it is going to have a component form 3, 2, with 3 as the horizontal component and 2 as the vertical component. Now right here we can say we can determine the directed distance r as the magnitude of the vector and the directed angle theta as the direction of the vector theta, right? So right here, in finding r, we know it's going to be magnitude. And so right here we can say that that's going to be the square root of 3 squared plus 2 squared, gives us the square root of 13. And if we want to define the theta, or the directed angle for the vector, then right here what we can say is we know that we can take inverse tan of the vertical component to the horizontal component, and that is going to give us the angle theta that the vector is going in, and so also the directed angle of our polar coordinate. So right here we would get 33.7 degrees. And then the polar coordinates that define the ordered pair 3, 2 would be square root of 13, 33.7 degrees. Okay, so right here, what you guys are going to do is try this on your own. We want to convert this point defined by the polar coordinates 4 and 240 degrees to rectangular coordinates. We're going to determine the rectangular coordinates for our point right here. And we want to similarly find the polar coordinates that define this point that is defined by the rectangular coordinates -2, 4. All right, so we'll pause the video and give that a shot. Okay, so right here we can say that the coordinate form of the vector that extends from the origin to our point is going to have a magnitude of 4 and a direction of 240 degrees, right, corresponding to the r value and the theta for our polar coordinates. So right here we can say then that the vector would look like 4 cosine 240, 4 sine 240, and when we evaluate these two numbers, we get the horizontal component of -2 and the vertical component of -3.46. And so right here, since we're extending from the origin, we know that the ordered pair defining our point right here with rectangular coordinates would be -2, -3.46. So these are the rectangular coordinates, or the ordered pair defining that same point. Okay, right here, converting rectangular coordinates to converting rectangular coordinates to polar coordinates. So basically, again, what we want to think is extend a vector from the origin to that point. That vector is then going to have the horizontal component of 2 and the vertical component of 4. And now, if we get the magnitude of that vector, that is going to give us the distance we have to travel from the origin. And if we evaluate the angle of that vector, we're going to get the direction that we have to extend that length in. Now, right here, when we're rotating to this vector, right, what we want to think is that this is a vector in the second quadrant, so we're going to have to add 180 degrees to inverse tan, and when we do that, we get our directed angle of 116.57 degrees. And so this right here would be the polar coordinates defining that point right there. Okay, so that's our second video. We got one more video to go, and we'll talk to you guys in that.